Good morning, ladies and gentlemen. Today, you should have done your joke worksheet yesterday for the sub. I will check in that joke worksheet when I return tomorrow, Friday. But until then, I am going to go ahead and go through your notes for today with you. And we'll assign your homework, and then we'll be back to normal tomorrow, Friday. Remember, next week you do have Monday off. We have teacher in service. And then Tuesday is midterm, meaning halfway through the fourth quarter. All right, so first thing I want to talk about is making sure that you know what an indefinite integral is. Okay, an indefinite integral means I'm going to do the antiderivative, but I do not have a specific interval that I'm doing that over. Okay, remember, when we have an antiderivative that we do not have intervals to plug in for, we need to put the plus c or the constant on the end of it to account for the variation that you could get. So if you take a look at my first example here, you will notice there are no endpoints on that integral symbol. There's nothing on that elongated s. So I just need to go ahead and do my antiderivative of this and then put a plus c on the end. So that would be my antiderivative, or the integral of this first example. Okay, if we go ahead and take a look at the next one, same thing. I just need to do my antiderivative here. And I'm going to put a plus c on the end because there are no endpoints for this integral. Notice that the antiderivative of e to the x is still e to the x because the derivative of e to the x is e to the x. And finally, just a little bit longer polynomial here. Again, I just wanted to be sure that you understand if there are no intervals that you are supposed to be specifically finding the area of, you must put your plus c on there for the constant. Okay, so hopefully that comes as no surprise to you. Okay, next topic I want to talk about today is multi-rule functions, meaning piecewise functions. If you have a piecewise function, you are going to need to split your integral into pieces. And when you do that, you need to be certain that you take care of the entire interval that you were originally supposed to do your derivative of. So if you take a look at this first example, I have a split that happens at the domain as 0. Okay, at x is 0 is where we jump from one to the other. So I'm going to split this integral into two pieces. I'm going to go from -1 to 0, and I'm going to go from 0 to 1. And that will give me the entire original integral. Okay, so when I do my antiderivative here, I'm just going to put the pieces in from -1 to 0. That is when x is less than 0. So that's what the first piece will look like. From 0 to 1 is when x is greater than 0. So that will be what my second piece will look like. So if I go ahead and do these antiderivatives, it would look like that. And now I need to go ahead and plug in those values. And I get that my final area under the curve is 5/6. Okay, in the first one, I get 0 minus a -1/2. And the second one, I get 1/3 minus 0. And then obviously we would be adding those together to find the final answer. Okay, another piecewise for you here. So if I'm going to break up this interval from 0 to 4, my first portion is going to go from 0 to 1. The second portion will go from 1 to 4. And then the portion from 0 to 1, the function is 1. and from 1 to 4, the function is x squared. Doing my antiderivative now. Looks like that. So if I go ahead and evaluate, this one gives me 1 minus 0. This one gives me 64 over 3 and 1/3 for a final area of 22. Okay, let's do one more piecewise before we move on to something else. All right, so I think I'm going to go ahead to split up my interval, and I'm going to go ahead and put the functions in right away. So the first piece will be from -3 to 0, and that is that part of the function. And then I'm going to go from 0 to 2, and then we have this part of the function. Remember, those parentheses are just keeping my polynomials together. Okay, that doesn't mean that I need to be doing chain rule here. Okay, so now I'm going to go ahead and plug in my numbers. And I get a final area of 17. I'm sure that you can probably guess where we're going after piecewise. We're going to go to absolute value functions because absolute values obviously can be written as pieces. So if I want to split this into two pieces, I still have the regular old positive piece and negative piece. Remember, my critical number happens where the absolute value is 0, and that happens at 4. 4 will make what's inside that absolute value be 0. So now I'm going to test something. If I test 0, I'm putting it into the original function. And if I put 0 into the original function, I get -8. Well, that is the negative piece. So I ask myself, where is 0 in comparison to 4? 0 is less than 4. So then you can go ahead and fill in your other two pieces. Okay, now I'm ready to split this up. This is going to go from 1 to 4. And that looks like it's the positive piece. And then we're going to go from, excuse me, that is not the positive piece. That should be the negative piece in there. Then we're going to go from 4 up to 9. And that's what my integral looks like. Let's go ahead and do our antiderivatives next. And now we're ready to plug in our values. This one gives me 16 minus 7. This one gives me 9 minus a -16. If I add them, I get a final area of 34. Another example of an absolute value. We're going to split into two pieces, the positive piece and the negative piece. The critical number here is whatever will make that absolute value be 0, which is 5/3. So if I put a 0 in there, 0 will give me a negative, which means I'm looking at the negative piece, and 0 is less than 5/3. Remember, it does not matter whether or not you put your less than or your equal to symbol on either piece. Okay, so when we split this, notice that we have to go from 0 to 5/3, and from 0 to 5/3 is the negative piece. Then we're going to go from 5/3 up to 4, and that's the positive piece. Antiderivatives. We're working with some fractions here, folks. Looks like that. Let's plug in our values. When all is said and done, and this first one, I'm going to do it a little bit different. I'm going to plug in that 5/3. And that's what I'm getting when I plug in 5/3. Okay, now I'm sorry, that's what I'm getting when I plug in 4. Now remember, I know what I get when I plug in 0. Should give me 0. Looks like that. You simplify that all down, I get 75/18. Over here, when I plug in 4, I actually get 4. When I plug in 5/3, it gets a little bit messy. So I'm going to kind of do it in 2 pieces here. And all together, I get that. If I add them together, I get a final answer of 37/3, or 12 1/3. Okay, last example for us here. One more piecewise. I've got 2 pieces to this. I've got the positive piece and I've got the negative piece. The critical number is 7. If I test a 0, I get a positive piece, which is the top one, and 0 is less than or equal to 7. Okay, so let's go ahead and split this integral up. I'm going from -2 to 7, and that will be this piece. Then I'm going to go from 7 to 10, and that will be this piece. Antiderivatives. Looks something like that. Okay, we go ahead and plug in these numbers. I get 49/2 minus a -16. And over here, I get -20 minus a -49/2, which gives me 45. So if I combine those together, if I combine those together, my final answer is 45. Okay. Let me know if you have any questions when I return, and we will take it from there. Hope you guys have a good day.